Today we are going through continuity on an open interval AB. In our last class we learnt about continuity at a point. So today we are going through continuity on an open interval AB or open interval or closed interval AB. So here continuity on open interval AB means, see, as I mentioned in introduction, see here continuity, a function is continuous in an open interval AB if it is continuous at every point of AB. Okay, here there are many points between A and B, right? So this function should be continuous at every point of open interval AB. Okay, then we say given function is continuous on open interval AB. The function f is said to be continuous on an open interval AB if it is continuous at every point of AB. Every point of AB. So here a function f is said to be continuous on open interval AB if this function f is continuous at every point of AB. Then what about a continuity on closed interval AB? Let's see. Continuity on closed interval AB. See, what is the difference between open interval AB and closed interval AB? Here in open interval AB, here A and B are not included. Okay, here A and B are not included, but the values close to A and close to B are included, right? That is greater than A and less than B. But here in closed interval AB, A and B are also included. Okay. So here, what about continuity on closed interval AB? Say a function f is said to be continuous function on an closed interval AB if it should be continuous on open interval AB, and I will write, okay, f is said to be continuous on closed interval AB if it is continuous on open interval AB. You have to study this definition, okay? So see what is the continuity on closed interval AB and continuity on open interval AB. So how you have to determine the given function is continuity on open interval and closed interval, okay? So here continuity on closed interval AB, if f is said to be continuous on closed interval AB if it is continuous on open interval AB and limit x tends to a plus f of x, that is equal to f of a, okay, and limit x tends to b minus f of x is equal to f of b, okay. So this equation should be satisfied, okay. So for this continuity on closed interval AB. So here limit x tends to a plus means the value greater than a, not a, greater than a, f of x, that should be is equal to value of the function at x is equal to a. And here limit x tends to b minus, okay, f of x is equal to f of b. So continuity on closed interval AB, how to determine given function is continuity on continuous function on closed interval AB. It should be continuous function on open interval AB and this equation should be satisfied. That is limit x tends to a plus f of x is equal to f of a and limit x tends to b minus f of x is equal to f of b. Okay, next is how we determine given function is a continuous function. There is no specific points and interval. Okay, so how when a function is continuous? See here, a function is continuous means if the function is continuous at every point in the domain of the function. Okay, if a function is continuous at every point of the domain of the function, then we say given function is continuous function. Okay. Next is algebra of continuous functions. If f and g are continuous functions, if f and g are continuous functions at C, okay, if f and g are continuous functions at C, then f plus g is continuous at C, f minus g is continuous at C, f into g is continuous at C, and f divided by g is also continuous at C. Here g of x, g not equal to 0. Okay. So if f and g are continuous functions at C, then f plus g is also continuous at the same point. Okay. F minus g is also continuous at C, f into g is continuous, f divided by g is continuous at C, and here the function g of x is not equal to 0. Next is some standard continuous function. Now let's see what are the standard continuous functions. Okay. So first one, constant function. Constant function. Constant function is continuous. How? Constant function is continuous. See, let's take a function, constant function, f of x is equal to k. Constant function means that function is equal to k, that is constant. Okay, k is a constant. So here domain is, okay, domain of this constant function is set of real numbers. Now let's take any point, any real number. Let C be any real number. Here, for continuous, what we have to prove? Limit x tends to C, f of x, that is equal to f of c, right? So let's find limit x tends to C, f of x. See, here limit x tends to C, what is f of x? K, that is equal to, see, whatever limit apply, here you will get the value is, value is constant, right? So its value is k itself, its limit after applying the limits also, this value is k itself. Okay, so limit x tends to C, k is equal to k. Then what is f of c? F of c is equal to, here our f of x is k, so f of c is equal to, it's a constant, okay, there is no variable to substitute value c, right? So therefore f of c is equal to k itself. So we have got limit x tends to c, f of x is equal to k, and f of c is also k. Therefore limit x tends to c, f of x is equal to f of c. Hence constant function is continuous. Second standard function is identity function. Okay, identity function is also continuous. How? See, what is an identity function? Identity function is of the form f of x is equal to x, right? If f of x is equal to x, see, this type of function is called identity function, right? So f of x is equal to x. Here is also domain R, set of real numbers, and let us take any point. Let C be any real number, okay, from the domain. And here also we have to prove limit x tends to c, f of x is equal to f of c. Okay. So what is limit x tends to c, f of x? That is limit x tends to c, f of x is nothing but x. Right? Now limit x tends to c, x. Substitute x is equal to c. Okay. So limit x tends to c, x is nothing but c. Right? Substitute x is equal to c. So limit x tends to c, x is equal to c. Next, what about f of c? F of c is equal to, here f of x is equal to x. So what about f of c? Substitute x is equal to c, right? In place of x, we should substitute x is equal to c. So f of c is equal to c itself. So we have got limit x tends to c, f of x is equal to c and f of c is equal to c. Thus limit x tends to c, f of x is equal to f of c. Therefore, the function, identity function is also a continuous function. Next one, polynomial function. Polynomial function is continuous. Polynomial function is also continuous function. Let's prove. What is the general form of the polynomial function? F of x is equal to an x raised to n plus an minus 1 x raised to n minus 1 plus etc. plus a2 x square plus a1 x plus a0, right? So it is the general form of the polynomial function. Here a1, a2, etc. all are in real numbers, okay? Set of real numbers belongs to real numbers. And here domain is also set of real numbers R. And see, let us take any point, okay? Any point from the domain. Let C be any real number. Any real number. Now, here also we have to prove limit x tends to c, f of x is equal to f of c, right? So, what is limit x tends to c, f of x? See, it is our f of x. That is limit x tends to c, an x raised to n plus an minus 1 x raised to n minus 1 plus etc. plus a2 x square plus a1 x plus a0. Right? See, directly you can substitute x is equal to c, right? See, after you substituting x is equal to c, you will not get 0 by 0 form, right? So surely we can substitute x is equal to c. So after substituting x is equal to c, what we will get? an c raised to n plus an minus 1 c raised to n minus 1 plus etc. plus a2 c square plus a1 c plus a0. So it is limit x tends to c, f of x. Okay. Next, we need to find limit, not limit, f of c. What is the value of the function? See, here also f of x is this one. So what about f of c? See, replacing x to c, right? That is the value substituting when x is equal to c, that is f of c. an c raised to n plus an minus 1 c raised to n minus 1 plus etc. plus a2 c square plus a1c plus a0. So it is the f of c. Okay, f of x is equal to this one. F of c is nothing but replace x by c. Okay, that is f of c is equal to substitute x to c. So here f of c is equal to, here we have got limit x tends to c, f of x is equal to f of c, right? Limit x tends to c, f of x is equal to f of c. Therefore, this polynomial function is also continuous. Okay, it's also a continuous function. Fourth function is modulus function. Modulus function is continuous. modulus function, that is modulus of x is continuous function. See, we have already done its proof, okay? So no need of proof here. So fifth one is every rational function is continuous. Rational function is continuous. Okay, let's prove. Every rational function is continuous. Rational function is of the form f of x is equal to g of x divided by h of x. Here h of x not equal to 0. It is the form of rational function, right? You know what is the form of a rational number, that is p by q. Here q not equal to 0. P and q are integers. Here rational function is of the form f of x is equal to g of x divided by h of x. Here g of x and h of x are polynomial functions, okay? And we know that every polynomial function is continuous, right? Therefore g of x and h of x are continuous, okay? G of x and h of x are, since g of x and h of x are continuous polynomials, okay? They are continuous, okay? They are continuous function. And here g of x and h of x are continuous. We know that if f and g are in algebra of continuous functions, we saw that here if f and g are continuous, then f by g is continuous, right? If f and g are continuous, then f by g is continuous. Here g not equal to 0, right? So here g of x and h of x are continuous. Then g of x divided by h of x is continuous, okay? Hence g of x divided by h of x is continuous. Here h of x not equal to 0. H of x not equal to 0. If h of x is equal to 0 means this function will not be defined, okay? That is denominator will be 0. So it will not be defined. So as g of x divided by h of x is continuous, here h of x not equal to 0. That is f of x is continuous. That means every rational function is continuous, okay? Therefore, every rational function is continuous. That's all. Next, what about trigonometric functions? See, sixth one, sine function is continuous. Okay, sine function is continuous. How sine function is continuous? Okay, now let's take f of x is equal to sine x. Here domain of sine x function is, sine function is set of real numbers. Okay, so let us take, let C belongs to R, any point from the domain. Let C belongs to R. Here also we have to prove limit x tends to C, f of x is equal to f of C, right? Okay, let's find limit x tends to C, f of x, that is equal to limit x tends to C sin x, f of x is equal to sin x. So here we are not going to substitute directly. Okay, so here let's take x is equal to a value, that is x is equal to c plus h. Okay, that is x is equal to c plus h. So here when this x changes, this limit also will be changed. Okay, therefore when x tends to 0 implies h tends to 0. How? You just substitute x is equal to c. Here x tends to c. Okay, not 0. X tends to c. Okay, substitute x is equal to c. So you will get h is equal to 0. So when x tends to c, h tends to 0. Okay, here substituting x is equal to c, you will get c is equal to c plus h. Take c here, you will get h is equal to 0. So Therefore, when x tends to c, h tends to 0. Why we substituting this value? See here, when we substitute directly, we cannot determine the function is continuous. Okay, so for that, we have to substitute x is equal to some value, that is c plus a small value. Okay, so that here we will get limit h tends to 0 sin c plus h. Okay, we have put x is equal to c plus h, so that this limit also will be changed. Okay, so here limit h tends to 0 sin c plus h. Okay, now limit h tends to 0 sin a plus b, it is of the form sin a plus b, sin a cos b plus cos a sin b, right? Sin a plus b is sin a cos b plus cos a sin b. So here limit of, okay, then apply limit for these two terms, that is limit h tends to 0 sin c cos h plus limit h tends to 0 cos c sin h. Here sin c is a constant. Okay, sin c is a constant. The only one variable is cos h. Okay, so we have to apply the limit only for cos h, right? So here sin c is constant, so we take it out, sin c into limit h tends to 0 cos h. So when here substitute h is equal to 0. See here no value, we have taken x tends to c. Okay, any real number, but here we can substitute, right? We can find the values. So limit h tends to 0. What is cos 0? 1, right? So sin c into 1. Sin c into limit h tends to 0 cos h. In limit chapter we have already learned these things. Limit h tends to 0, sin c is constant, take it out. So limit h tends to 0, cos h is cos 0, that is 1, plus cos c into limit h tends to 0 sin h. Okay, here cos c is constant, take it out from the limit. Limit h tends to 0, sin h is, substitute h is equal to 0. We know that sin 0 is 0. Therefore, cos c into 0, that is equal to sin c. Okay, we have got limit x tends to c, f of x is equal to sin c. Then, next, what is f of c? F of c is equal to, see, f of x is equal to sin x. What is f of c? Substitute x is equal to c, right? That is sin c. So here we have got limit x tends to c, f of x is equal to f of c. Hence, the sine function is continuous. Next one is cosine function is continuous. Cosine function is continuous. So here f of x is equal to cos x. Here also the domain of the cosine function is R, set of real numbers. Here also let's take c belongs to R, any element from the domain R. Okay, so here first of all let's find limit x tends to c, f of x, that is equal to limit x tends to c cos x, that is equal to, here also put x is equal to c plus h. So when x tends to c implies h tends to 0, right? So don't forget to see, when you change the value of x, this limit also will be changed, okay? So don't forget it to change the limit. So limit x tends to c cos x, so that is equal to limit h tends to 0 cos c plus h, that is equal to limit h tends to 0 cos of a plus b. It is of the form cos of a plus b, right? Cos a plus b is cos a cos b minus sin a sin b, right? Now apply this limit for both terms. Limit h tends to 0 cos c cos h minus limit h tends to 0 sin c sin h. That is equal to, here cos c is constant, right? Cos c is constant, only the variable is cos h. So substitute the limit value h tends to 0 to cos h. So cos 0, that is 1. So cos c into 1 minus, here sin c is constant. So sin c into h tends to 0, that is sin h. So sin 0 is 0. So sin c into 0, that is equal to cos c. Now what is f of c? F of c is nothing but cos c, right? So f of c is equal to cos c. So we have got limit extends to c f of x is equal to f of c. Therefore cosine function is continuous. Next is tangent function is continuous. Tangent function is continuous. Okay. We know that tan x f of x is equal to tan x, that is equal to sin x divided by cos x. Okay. And we know that sin x and cos x are continuous, right? Therefore sin x divided by cos x is also continuous. Therefore tan x is continuous. But here what is the domain? Domain of the tan function is r minus 2n plus 1 pi by 2. Okay, it is the domain of the tangent function. Okay, therefore tangent function is continuous at C. If we take any point from the domain, means that C belongs to r minus 2n plus 1 pi by 2. See why this one? Here divided by cos x is there, right? See, if cos x is equal to 0, this will not be defined. Therefore, the domain is r minus 2n plus 1 pi by 2. Because we know that, see, just substitute n is equal to 0, pi by 2, cos pi by 2 is 0. And cos 3 pi by 2 is 0. Okay, cos 5 pi by 2 is 0. Therefore, the domain of the tangent function is r minus 2n plus 1 by pi by 2. Okay, therefore, this tangent function is continuous at C. This C belongs to r minus 2n plus 1 pi by 2. Okay, because here sin x and cos x, see tan x is equal to sin x divided by cos x. Sin x and cos x are continuous function. Therefore, sin x divided by cos x is also continuous. Hence, tan x is continuous. Tan x is continuous at any point belongs to this one. Okay, domain of the tangent, that is r minus 2n plus 1 pi by 2. Now let's go through some examples. Check the continuity of the function f given by f of x is equal to x sin 1 by x, x not equal to 0, and f of x is equal to 1 when x is equal to 0. So here we have to check whether given function is continuous or not. So here, first of all, limit x tends to 0, right? X tends to 0, f of x is equal to limit x tends to 0, x sin 1 by x. Okay, here x tends to 0 means x is not equal to 0. Okay, x is, that is x approaching to 0. Okay, left or right, it is near close to 0. So what is the value, limit value? When limit x tends to 0, x sin 1 by x. See, here we substitute x is equal to 0. So what we will get? 0 into a finite number that is between minus 1 and 1. Okay, here we substitute x is equal to 0, but here x not equal to 0. Okay, x is not equal to 0. So when you substitute a value that is close to 0, you will get a finite number between minus 1 and 1, because we know that the range of a sine function is closed interval minus 1 to 1, right? Therefore, here we will get a finite number between minus 1 and 1, right? A finite number between minus 1 and 1. Therefore, here 0 into any finite number between minus 1 and 1 is nothing but 0 itself, right? So, here we have got, it is limit x tends to 0, f of x is equal to 0. Next, what about f of 0? Okay, what is f of 0? Here we have to prove for continuous function limit x tends to 0, f of x is equal to f of 0, right? That is limit x tends to c, f of x is equal to f of c. That is our definition, continuous function definition. So we have to prove limit x tends to 0, f of x is equal to f of 0. So let's find f of 0. What is f of 0? See, in function given that if x is equal to 0, the function f of x is equal to 1. So therefore f of 0 is equal to 1. But here limit x tends to 0, f of x is equal to 0, f of 0 is equal to 1. Hence, limit x tends to 0, f of x not equal to f of 0. Okay. Therefore, this given function is not continuous. Okay. This function is not continuous. Consider f of x is equal to 3x minus 8, x less than or equal to 5, 2k, x greater than 5. Okay, f of x is equal to 2k and x greater than 5. Find the value of k if f of x is continuous at x is equal to 5. So here very important question, 2007 and 2013 question. So here it is given that given function is continuous at x is equal to 5. So we need to find the value of k. Okay, we have to find the value of k. So if this function is continuous, we can write, see, it is given when x less than 5, the function is this one. When x greater than 5, this function is this one. So here we can find a left hand limit and right hand limit, right? So let's take limit x tends to 5 minus f of x is equal to limit x tends to 5 minus, what is f of x? 5 minus means left of 5, that is less than 5. So the function is 3x minus 8. That is equal to, now just substitute x is equal to 5. What you will get? 3 into 5 minus 8, that is 15 minus 8 is 7. Okay, next, limit x tends to 5 plus, okay. Why this left hand limit and right hand limit? See here the function is given x when x less than or equal to 5, then x greater than or equal to 5, another function, right? So here we have to, here it is given, it is function, continuous function at x is equal to 5. So it is better to find left hand limit, right hand limit, okay. F of x is equal to limit x tends to 5 plus, what is the function? 2k, right? When x greater than 5, 5 plus means x greater than 5 plus. 5 plus means right hand limit, that is x value is greater than 5 and it is very close to 5, okay? That is 2k. So 2k is a constant, okay? So its limit is 2k itself, okay? And it is given that the function is continuous. Okay, now let's find the value of the function. That is f of 5. What is f of 5? F of x is equal to, see, f of 5 means when x is equal to 5, right? So when x is equal to 5, the function f of x is equal to 3x minus 8, right? That is 3 into 5 minus 8, that is equal to 7. Okay, so here it is given that it is continuous at x is equal to 5, right? That means this should be equal, right? Left hand limit and right hand limit should be equal. That should be equal to value of the function. So we can equate any of these, okay? 2k is equal to 7. That implies k is equal to 7 by 2. The value of k is 7 by 2 if f of x is continuous at x is equal to 5. we are going through NCERT textbook exercise 5.1 questions. Okay. Here, first one, prove that the function f of x is equal to 5x minus 3 is continuous at x is equal to 0, at x is equal to minus 3 and at x is equal to 5. We will prove it one by one. Okay. So, according to the continuous function definition, we have to prove limit x tends to, say first 0, limit x tends to 0, f of 0 equal to f of 0, right? So, first of all, write what is given function 5x minus 3. Okay. Then, let's find limit x tends to 0, f of x is equal to limit x tends to 0, 5x minus 3. Here, put x is equal to 0. See, don't be confused here when substituting, when applying the limit. See, for every limit function, you have to substitute the value first. Okay. So, after substituting, when substituting, if you are getting 0 by 0 form, then you have to apply some other method. Okay. So, first of all, you have to substitute the limit value. That is, when x tends to 0, x tends to 0 means it is x is near to 0. Okay. So, what is the limit of this function? Okay. So, here substitute x is equal to 0. We got minus 3. Okay. See, these all things you studied in limits chapter. That's why I told, see, first of all, go through limits, then come here. Okay. So, here we have got limit x tends to 0, f of x is equal to minus 3. Then, what is f of 0? F of 0. Our f of x is 5x minus 3. What is f of 0? Substitute x is equal to 0, right? So, in place of x, we should substitute 0, right? So, 5 into 0, 0, 0 minus 3 is minus 3. So, we have got limit x tends to 0, f of x is equal to f of 0. That is, hence, we say that this given function is continuous function at x is equal to 0. Okay. Next one. Here, next we have to prove given function is continuous at x is equal to minus 3. Right. So, for that same method, limit x tends to minus 3, f of x is equal to limit x tends to minus 3. What is the function? 5x minus 3. That is equal to, here also, first of all, substitute x is equal to minus 3. So, what we will get? Minus 5 into minus 3, minus 15, minus 3, that is minus 18. Right? So, next, we will find f of minus 3. F of x is this one. What is f of minus 3? In place of x, we write minus 3, right? So, substitute x is equal to minus 3. So, here also minus 15, minus 3, that is minus 18. So, here we say function is continuous at x is equal to minus 3. Next, third point is x is equal to 5. So, here also we have to prove this function is continuous at x is equal to 5. So, for that, limit x tends to 5, f of x, that is equal to limit x tends to 5, f of x is 5x minus 3. Here also substitute x is equal to 5, 25 minus 3, that is 22. Then, what is f of 5? F of x is this one. F of 5 is nothing but 5 into 5 minus 3. That is 25 minus 3, that is 22. So, here also we have got limit x tends to 5, f of x is equal to f of 5. Hence, given function is, that is f of x is equal to 5x minus 3 is continuous at x is equal to 0, at x is equal to minus 3 and at x is equal to 5. Second question is, examine the continuity of the function f of x is equal to 2x square minus 1 at x is equal to 3. Given function is f of x is equal to 2x square minus 1. So, here we have to check whether given function is continuous or not. So, for this also, first of all, we will find limit x tends to 3. Okay, where x tends to 3, f of x. Limit x tends to 3, f of x, that is equal to limit x tends to 3, our function is 2x square minus 1, that is equal to, substitute x is equal to 3, okay. So x is equal to 3 square, that is 9, okay. 2 into 3 square minus 1, that is 3 square 9, 9 into 2 18, 18 minus 1 17. Next let's find f of 3, okay. We have to prove limit x tends to 3, f of x is equal to f of 3 for continuous function, okay. Let's check. F of 3 is 2 into, f of x is this one, f of 3, substitute x is equal to 3, so 2 into 3 square 9 minus 1, that is 17, okay. So here limit x tends to 3, f of x is equal to f of 3, hence the given function is f of x is continuous at x is equal to 3, okay. Third one is examine the following functions for continuity. First one, f of x is equal to x minus 5. See, here we have to check whether given function is continuous function or not. So that is not any specific point, okay, not at any specific point. So here let's prove one by one, okay, let's check it one by one. First one, f of x is equal to x minus 5. See, we know that f of x is equal to x minus 5, it's a polynomial function degree 1, right? It's a polynomial function of degree 1, and we have every polynomial function is a continuous function, right? So here we say f of x is equal to x minus 5 is a polynomial function and it is continuous. It is continuous function. Okay, because we know that every polynomial function is continuous. Next, b, f of x is equal to 1 divided by x minus 5. See, function 1 divided by x minus 5, when we substitute x is equal to 5, this function will not be defined, right? That is 1 by 0, it's not defined. So here we say this function is not continuous at x is equal to 5. F of x is not continuous at x is equal to 5. Then what about other points of the domain of the function? See, here we know that this function is nothing but it is the rational function. Okay, it is the rational function, and we know all the rational function, every rational function is continuous function. So it's a rational function. F of x is equal to 1 divided by x minus 5. Here x not equal to 5 is a rational function. Okay, so at x not equal to 5, this given function f of x is equal to 1 by x minus 5 is continuous function. Okay, this function is continuous function at every point but x not equal to 5. Okay, except x is equal to 5, this function is continuous. Okay, this function is continuous at every point in the domain of the function except x is equal to 5. Okay. Next, see, f of x is equal to x square minus 25 divided by x plus 5. F of x is equal to x square minus 25 divided by x plus 5. See, here also, when we substitute x is equal to minus 5, this function will not be defined. Okay, we will get 0 in denominator, right? So this function is not defined when x is equal to minus 5. Therefore, this function is not defined at x is equal to minus 5. Okay, is not defined at x is equal to minus 5. Okay, and otherwise this function is a rational function, right? So f of x is equal to x square minus 25 divided by x plus 5 is a rational function here x not equal to minus 5. Okay, and we have every rational function is a continuous function, therefore this function is continuous. Simply we can write f of x is continuous function at x not equal to minus 1. That means this function is continuous at every points of the domain of the function except x is equal to minus 5. Okay, so at x is equal to minus 5 this function is not continuous. Now let's check fourth one, if it is continuous or not. F of x is equal to modulus x minus 5. Okay, these functions can be defined as f of x is equal to x minus 5, that is we know that modulus x can be defined as minus x when x less than 0, right? So here minus of x minus 5 when x less than not 0, here 5, okay, when x less than 5. Here minus, not minus, x minus 5 when x greater than or equal to 5. Okay, similar to this one, modulus x. Okay, so here modulus x means it is minus x when x less than 0. It is plus x when x greater than or equal to 0. Here our modulus function is x minus 5. So it can be defined as minus x minus 5, x less than 5, x plus x minus 5, x greater than or equal to 5. See here, it is nothing but, once again we can write, it is minus of x minus 5, that is nothing but 5 minus x, right? After multiplying minus to each terms, so 5 minus x. Okay, so here when x less than 5, the function is 5 minus x, it is nothing but a polynomial function of degree 1. And here when x greater than 5, the function is x minus 5. So it's also a polynomial function, and we know that every polynomial function is continuous. Okay, so here we can write when x greater than 5 and x less than 5, function f of x is continuous. Okay, that is this function is continuous at x less than 5 and x greater than 5. Then what about x is equal to 5? See here, that we have to check. Okay, when x is equal to 5, we have to check whether this function is continuous at x is equal to 5 or not. See, for that, let's find the left hand limit and right hand limit. So here limit x tends to 5 minus f of x is equal to, okay, this one you understood, right? That is when x greater than 5 and x less than 5, these functions are a polynomial function. Therefore, here when x greater than, this function is continuous at x less than 5 and x greater than 5. Now we have to check this function is continuous at whether this function continuous at x is equal to 5. Okay, so here limit x tends to 5 minus. 5 minus means that is left of 5 less than 5. The function is limit x tends to 5 minus. Function is 5 minus x, that is equal to, substitute 5 here, so you will get 0. Then what about right hand limit? When limit x tends to 5 plus f of x, that is equal to limit x tends to 5 plus, here 5 plus means right of 5, that is greater than 5. When x is greater than 5, the f of x is x minus 5, that is equal to 5 minus 5, 0. Okay, so here we have got left hand limit and right hand limit are same. So limit x tends to 5, f of x exists. Okay, then what about f of 5, right? We have to find f of 5. That means f of 5 means when x is equal to 5. When x is equal to 5, what is the value? X minus 5, right? f of 5 that is x minus 5 that is 5 minus 5 that is 0. Right? So here also we have got limit x tends to 5 minus that is equal to limit x tends to 5 plus f of x that is equal to f of 5. So therefore this function is continuous at every point in the domain of the function. So we can write given function f of x is equal to modulus x minus 5 is continuous at a no need of continuous function. Okay, f of x is equal to modulus x minus 5 is continuous function.